Hello and welcome back to Mathics. In this video, I will do AMC 10A problems. It's going to be only problem 1 to 10 for now. I will just do the rest of the questions and upload them later. And before I start, one thing, if you need coaching or if you need somebody who needs coaching, okay, I have my contact information on the about page of my channel. I also have my email address right over here. Some more contact information in the description box below. Contact me and we could have classes together. Okay, problem 1. Cities A and B are 45 miles apart. Okay, Alicia lives in city A, so I'm just going to write A for Alicia. And Beth lives in B. Alicia bikes towards B at 18 miles per hour. So this goes with the speed of 18 toward B. Okay. Leaving at the same time, Beth bikes toward A at 12 miles per hour. Okay. How many miles from city A will they be when they meet? Okay. So because they go together, right, they will meet each other sooner. Okay. So that means together they will have a speed of 30 miles per hour. Okay. So after 1 hour, together they go 30. Okay. In 2 hours, they go 60. But all of this is 45. Okay. So we're going to go, it's going to be more than 1 hour, less than 2 hours. So we know it's going to be the distance, 45 miles, divided by the speed they have, okay, which is 30. So it's going to take 1.5 hours, okay? So now what do we want here? It says, okay, how many miles from city A will they meet, okay? So from here, because we want from city A, let's go from here. In 1.5 hour, how far has A gone? In 1 hour, it goes 18, right? In 1.5, it goes half of 18, which is 9. So it will be, you could write it like this, 18 plus extra 9, 27. Or you could write it like this, that speed is 18. It's continuing with the same speed for 1.4 hour. Okay, so it's going to be 27. 27 is going to be more than half, so it's going to be 27 over here. But remember one thing, okay? If we multiply this 1.5 by 12, okay, it's going to be 18 over here. So the answer will be 18 from B, 27 from A. So, of course, the answer will be E. Okay, problem 2. The weight of a third of a large pizza. For pizza, I'm going to put P. Okay, so we're going to have a third of a pizza together with 3.5 cups of orange slices. I'm going to write this as 7 over 2. And for oranges, I'm going to just use R instead of O, not the first letter, because it will be mixed with 0. We don't want that. So it's got to be 7 over 2 R's. Okay, oranges is equal to 3/4 of a large pizza and half of R's. Okay, so what should we do now? P's on one side, R's on one side. We need to do that. Okay, so I'm just going to write it here and clean it, okay, in case you need it. So from both sides, I'm going to minus, okay, half an R to get rid of this, okay. And both sides, I will also minus it by 1/3 of P, okay. So we're going to get this. I'm not going to write a lot of details, okay, because this is like AMC 8, AMC 10. Okay, so to do that, it's going to be, when we do that, we'll have 6 over 2r is going to be like 3r is equal to, okay, 3/4 of p minus 1/3 of p, okay? So we're going to take out p because they're common. So we're going to have 3r is equal to, okay, 3/4 minus 1/3, all of it multiplied by a p, okay? So we're going to get again 3r is equal to, okay, 12 is 4 times 3, 3 times 3, 9 minus 4, okay, which is going to be 5 over 12p. So, okay, now because we want the value of p, so I will multiply both sides by 12 over 5, okay, also this side. So the reason I do this is because they will cancel, right? So what we're going to do after doing this, okay, so 1p will be 3/6 over 5 of r. So this p and r was not that good of an idea, right? It's a little confusing. So oranges, okay, for oranges, what we're going to have, it was saying that a cup of oranges is 1/4, okay, of a pound. So instead of oranges, we're going to get 1 over 4. So this 4 cancels, simplifies with this. It's going to get 9 over 5. So P will be 9 over 5, which is going to be equal to 1/4 over 5. So A is the right answer. Okay, problem 3. How many positive perfect squares less than 2023 are divisible by 5? Okay. So what is the smallest one, which is a square number divisible by 5? 2 squared, 3 squared, 4 squared. The first one is 5 squared, or 25. Okay. So what is the next one? So is 5 squared multiplied by 2 or 3? Is that going to be a square number? No. We need a number. We need to multiply it by another number that is also squared. So in other words, we want a number that here it has an even number. If it's odd, it's not going to be a perfect square. Okay, so 5 squared is the first one. The next one will be 5 squared multiplied by 2 squared, which is going to be, we don't need it, but it's going to be 100. The next one will be 5 squared multiplied by 3 squared, okay? So we just have to continue like this, okay? This one is 225. So you just have to come up with the last one. So the last one will be 5 squared multiplied by, you just make a guess and check, okay? My guess would be, let's go with 10. If I go like 10 squared, okay, this would be 100 multiplied by 25 will be 2,500, which is way off. I'm larger. Okay, so that's not going to be it. So not a good guess. How about 9 squared? Okay, you check that. It will be 2,025. It would be slightly more than this. Okay, so the last one, the biggest one you could go with is going to be this one, 5 squared multiplied by 8 squared. You could write this as 40 squared, which is going to be 1,600. It's definitely less. Okay, so just when you want to count this one thing, the first one is started by 1. Okay, 1, 2, 3, and the last one is 8. Okay, remember, this could be sometimes, if you only check the last number, you see 8 number, you could make a mistake, especially if the beginning number starts with the 0 when you're counting. Okay, you always check that. The first one is 1, the last one is 8, so we have 8 numbers. Okay. Okay, problem 4. Well, if you have seen a question like this, a similar question, well, to do this, you just need 1 second to completely find the answer. Uh, okay, let's read the question. A quadrilateral has all integer side lengths, a perimeter of 26, and one side of length 4. What is the greatest possible length of one side of this quadrilateral? Okay, now let's see here. If you have seen a question like this, you just need to divide this by 2. Okay, and once you do that, you just want to find the next integer that is a little smaller than it. So it's just 13. One integer lower than 13 is going to be 12, and that's it. But why is that? Let me explain. Now let's understand this idea using a triangle first, then we apply it to this quadrilateral as well. Okay, so now if we have 8, and 8 is larger than 5 plus 2, you see, it doesn't matter what angle we have, even if I bring this down all the way here, and if I bring this 2 over here, okay, you will see that it's not going to be enough, okay? Now if I make this one 3, however, like if the green one is 3, okay, so not 2, if this one is actually 3, right, if it's just going to be equal, even if we go with 0 degrees, okay, both of them are going to be like this. But if they are a slightly larger, like if this, for example, this one is 3.2, okay, that's going to be enough to make a triangle. Okay, but the angle at which the triangle is made is going to be small, right? It would be, if it's 3.2, it's going to be, if I can make it something, your triangle will look something like this. Okay, it's going to be a little larger. That would be your triangle. Okay, so it needs to be a little even larger than half. Okay, so let me draw a quadrilateral and we deal. So now imagine, okay, we have the perimeter of the quadrilateral is 26. Okay, and one side is 13. Okay, and it says the book that one of them is 4, like in the question. So the perimeter, what do we have? What is left? 26. Okay, it's going to be 26. It's not writing. So 26. Okay, it's working now. 26 minus 13 minus 4. Okay, it will be 9. Okay, so, and it's going to, this 9 is going to be 2 different lines. You see that this 9 will be completely on top of this. So it doesn't matter. Like if this side is like this, the other one will also fall into it with a different color, right? The sum of these two still will be 9. So this will be 9. It's not going to work. You're not going to have a quadrilateral. But because here it says it's going to be a integer side. So if 13 doesn't work, okay, so all we have to do is just make this one a little shorter. If this is 13, okay, now you have 14. Okay, so if this one is 4, so let me just draw a line of 4. Okay, so what is left? We have like 10. 13 plus 4 is 17. Okay. I'm sorry, it has to be 12. Change that into 12. So if we make this 12, the sum will be 16. We have 10 left. Okay, so we could have our quadrilateral because it will be larger. Like this, it doesn't matter how you draw it. So it's possible to draw something like this. So we could make infinite shapes like this. Okay, so it doesn't matter as long as the sum of these 3 sides, the yellow one, the red one, and this one, okay, is more than this 12, we could make our quadrilateral. So all you had to do is just divide 26 by 2, okay? If it's going to be exactly half, it's not going to work. You go just 1 below the half, okay? So it will be 12, the right answer. And remember, this 4 was basically just over here to confuse you, okay? So now you think, whoa, what a difficult question. Okay, problem 5. How many digits are in the base 10 representation of this number? Okay, so to do this question, you need to know power rules. And that 10 is equal to 2 times 5, really. And 100, okay, is equal to, okay, 2 of this, right? So if you have 2 times, each 0 is equal to 1, 2 times, and 5. Okay, so you take 0, 1 0 is equal to a 2 multiplied by 5. That's all you need to do. Okay, so this one, okay, 8 we know is 2 to power of 3, again to power of 5. Okay, so this would be 2 to power of 15. Okay, you just multiply 3 by 5. Okay, and this will be 2 to power of 15 multiplied by 5 to power of 10. And 15, I'm going to write it as 5 to power of 5 multiplied by 3 to power of 5. Okay, so this is 15. Okay, so now we have these powers 5 and 5. So because the bases are the same, I'm going to add the powers. Okay, so it will be 2 to power of 15 multiplied by 5 to power of 15. Okay, and 3 to power of 5. Okay, good. So as I said at the beginning, this will create 15 zeros. Okay, and this number, we know that 3 to power of 4 is 81. This is going to be like 81 times 3. It's going to be a 3-digit number, right? It's going to be like 323. So we're going to have 3, 2, 3, 3 digits, and 15 zeros like this. Okay, so it will be a total of, okay, 18 digits. Okay, now one extra thing, right? So I know some of you will just have a little problems with power rules. Okay, so if you have, for example, this one, why is this 2 to power of 15? Okay, remember, what was power? What was the definition of power? It was multiplying a number by itself. Okay, so we have to multiply 8 5 times. Okay, it's just going to be, I could write it as 8 times 8, like this number. Let's take this one. This was 8 times 8 times, okay, 8 times 8. Okay, so we're going to repeat this, okay, 5 times. And each one, it will be like 2 to power of 3 multiplied by 2 to power of 3. And it's going to be like this. Okay. So we just, and when it's like this, you could just come up with easy examples and try them yourself, right? So, right, if you're ever confused, do I really need to add all these threes together? Okay, make an example like you know that, okay? So 2 to power of 3 multiply 2 to power of 2. Okay, so you know that this is 8. You know that this is 4. Okay, you know that the answer is 32. And you know that 32 is equal to 2 to power of 5. So what did we do here? We added the powers together. So if you ever forget, right, you're doing in the middle of test, it's not a good idea, but you just come up with really simple examples that you know, you apply them, you make the formula, okay, in case you forget it. Okay, so that's E. Let's do the next one. Okay, problem 6. Well, I'm pretty sure a lot of the students will waste so much time on this question, right? If you write down like I spent 15 minutes on this question, I would believe you, but it's actually not a very difficult question. Okay, so let's see here. An integer is assigned to each vertex of a cube. Okay, let me draw a cube very quickly. Okay, so we're gonna have a cube like this. Okay, So this question is going to be extra difficult for non-native ones like our Chinese or Asian uh, participants because it has a lot of words that they might not know. Okay, so here is each vertex of a cube, okay? So vertex would be each point, okay? And if it's just more than one vertex, it becomes vertices, okay? So, and we're gonna just put like some numbers on each of these vertices, okay? And here it says the value of edge would be, each line will be an edge, okay? So edge is this, the point is V, and all of this page, okay, all of this will be a face, okay? A value of an edge is defined to be the sum of the values of the two vertices touches. Okay, so I'm going to just call this one as an example A and just put some random numbers here. These are random numbers like 2 and this one 5. Okay, so now it says, okay, the sum of the values of the two vertices touches. So this side, this one will be A plus 2, this edge, okay? And this one, okay, will be A plus 5, okay? And the value of the face is defined to be the sum of the values of the 4 edges surrounding it, okay? Now, this face, all of this face, we're going to talk about this, okay? This is a random point A, okay? So when I want to sum these two together, okay, so you will see that I'll just have to go A plus 2 and then A plus 5. So you will see that this random one, okay, this point, okay, repeated 2 times, okay? So for this face, so now when we add this face, we're going to have 2A, okay? And this point is also shared on this page, okay? So this will get another 2A, okay? And the one behind it, this page behind it, will get another 2A, okay? So because one vertex, one point is shared with 3 pages, 3 faces, okay? And each A is repeated 2 times, okay? So that's will make 2A multiplied by 3. So that means each point, okay, will be repeated 6 times, okay? This was A, I called it A, and I chose this one at random, right? So if this one is called B, B will be repeated 6 times. Whatever it is, it will be repeated 6 times. So each vertex will repeat it 6 times, okay? So we know that the sum of them is 21, and each one will be repeated 6 times. So we really have to go 21 times 6 is going to be 126, okay? No, very difficult. Okay, problem 7. Janet rolls a standard 6-sided die 4 times and keeps a running total of the numbers she rolls. This could be a little weird. So what's the meaning of running total of the numbers? Like she just throws the dice, okay, roll it. Maybe it's just like brings a 3. Okay, then the next time it rolls it, maybe brings a 2. It just like keeps adding them, right? That's like the total. Running means it does it with each time that it rolls the dice, okay? What is the probability that at some point, maybe the first time, maybe the second time, maybe the third time, her running total will equal 3, okay? So I threw it, right? I rolled the dice. There's 6 possibilities. If I bring a 3, that's it, right? So from 6, if I bring a 3, that will be 1 over 6, okay, plus. So what if I bring 3 the second time, right? So the first time 6 possibilities, I throw it twice, it will be 6 squared. So how is that possible for me to get a 3? Okay, maybe the first time I get a 1 and the next time I get a 2. Maybe the first time I get a 2, the next time I get a 1. Okay, this time if I get a 3, it's not going to be, because the total would be 1 plus 3. So only 2 possibilities. Plus. So the third time I roll the dice, okay, will be 6 squared. So when we throw dice, there's no 0, is it? So the only way to get 3 is just the first time I get a 1, the second time I get a 1, and the third time I get a 1 again. So it will be like this. Is it possible to get a total of 3 with 4 roll of a dice? No, so it'll be like 0. Okay, this one was just there probably to just confuse us. Okay, so we just need to add all of these. Okay, so, okay, this one, 3 squared will be 3 cubed will be 216. This will be 36. Okay, this has been multiplied by 6, so plus 12 plus a 1. Okay, you add them all up. It becomes 49 over 216. So B is the right answer. Okay, problem 8. I think to do problem 8, if it's unclear for you, you need to graph something, sketch something. And this is exactly what we're going to do for this problem. Barb, the baker, has developed a new temperature scale for a bakery called Breadis scale, which is a linear function of the Fahrenheit scale. Why did the question have to say this? Okay, so it's just linear. It means like this, for example, inch and centimeters. Like an inch is always 2.54 centimeters. Okay, if it's not linear, for example, if it's exponential, right, between some two things, it would be like this. First 1 inch at the beginning, for example, 1 inch is 2.54. After, for example, 20 inches, this will change. For example, if it's not linear, then 1 inch could be 1.5. It could be 3. It keeps changing. But here it says the ratios are constant. That's why it's saying which is a linear function of the Fahrenheit scale. Okay, so bread rises at 110 degrees, okay, Fahrenheit, which is 0 degree on Breadis scale. Okay, so let's just go. I want to just draw two things very quickly. Okay, so up, the higher is up. Okay, so for example, this could be Fahrenheit 0. I'm not gonna make purple. Okay, so bread rises at 110 degrees Fahrenheit. Okay, so imagine this is 100. Okay, so this would be 110. Okay, this 110 will be the 0 of the other one. So this is going to be like, okay, this one, for example, is B. This one is Fahrenheit. But for this one, we just call this 0. Okay, now let's continue reading. Bread is baked at 350 degrees Fahrenheit, okay, which is 100 degrees at the Breadis scale. So we have to go 350, this is 100, 200, let me make it purple again. So this would be 200 again. We go up, this is 300 again. Okay, so this will be 350, okay. So if I continue this, okay, so this would be 100. So now we need to see one scales, okay? So we just need to know 1B is equal to how many of this, okay? So 100 was between this distance. It's 350 and 110. So I'm going to write 350 minus 110, okay? Divided by this. We want to know how large is this newest scale, okay? So 240 divided by 100 is going to be 2.4. So this is going to be larger. 1B will be a larger scale than a Fahrenheit. So 2.4 Fahrenheit. Okay, so this is what we have. So let me do some cleaning here and read the rest of the question. So here it says bread is done when its internal temperature reaches 200 degrees Fahrenheit. Okay, so our 0 was at 110 and we need to reach this 200 right over here. Okay, so we want to know how much is that. Okay, in Fahrenheit, this is going to be 200 minus 110. Okay, which is going to be, of course, 90. Okay, so, but this 90, this distance, this 90 is in Fahrenheit. Okay, we need to divide it by 2.4 to get it in B temperature, Bredesen scale. So it's going to be like this. Okay, so do this however you can. I'm going to write this as 45 divided by 1.2. Okay, so it will be 45. Okay, 5/6. So we could simplify this by 3, so it will be 75/2. So the temperature will be 37.5. It will be right over here. Okay. Well, problem 9, I think this one is not an easy one. It's a little challenging to understand, and you need to be very organized when doing it. Okay, so let's do problem 9. A digital display shows the current date as an 8-digit integer consisting of a 4-digit year, for example here, 2003, this part, followed by a 2-digit month. So here is going to be the 4th month, April, followed by 2-digit date, 28th of the month. So for example, this day is in this year is displayed as this. So for how many dates in 2023 does each digit appear an even number of times in the 8-digit display for the date, right? So probably when you read it this time, if you don't understand, that's okay, I think. So nobody probably get it the first time. Just have to read it. Like each digit appear at an even number of times. So for example, right now 3 has happened once. Is that an even repetition? No. So 3 has to be repeated more. Okay. So here it says this year. Okay. So let's write it down. It's going to be 2023. So this one is forced already. Okay. We just have to decide for these other 4 numbers. Okay. 2 has repeated 2 times already. Okay. So 3 needs to be repeated once and 0. Okay. So can 3 be here? Do we have, well, the maximum number for months is 12. Of course, 3 can't be here. We don't have 30 something months. Okay. So that's good. So 3 could be here, like the 3rd month. Okay. Do we have 13 months? No. So we only have 1. If 3 is here, then 0 will be forced like this. Okay. So 3 has repeated, 0 has repeated. So we need, if I put here, can I, for example, write 15 here? No, because 5 will be odd, 1 will be odd. So whatever I write, I have to repeat it. So it would be 11. or it could be 22nd. 33 will not work, right? A month is maximum 31 days. So if it's like this, we'll have 2 repetition like this, if 3 is here. So let's just go, we're doing a case work, right? So what if 3 is in this position? So if 3 here, we could have the 30th day, or we could have 31st day, like it's going to be like here. If it's 30, so we need another 0, okay? So let's just go here. For example, if I have a 0, okay, so no, I'm sorry. So 0 has already been repeated. So 0 is okay, okay, 3 is already okay. So what months can I write here? Only the 11th, right? There is nothing else. So it will be only 1. So what if I just have 31st? Okay. So now I need another 0 and I need a 1. So it could be like the first months of the year or the 10th months of the year. So 2 more possibilities like that. Okay, let's just let them be here. Okay. So the last place will be something like this. So we'll have 2023. And so what if the 3 is in the last place? Okay, it could be the 3rd of the month, 13th of the month, 23rd of the month. Okay, if it's 0, so everything already there, we could have only the 11th month. So it will be like 1. Okay, if this is 13th, so we need another 0, okay, and another 1. So maybe 10s again, maybe 0 and 1. Okay, so it will be 2 more possibilities like this. Okay, so and at last, what if this one is 23rd of the month? Okay, then we need another 0. Okay, it's like 0 and a 2 right over here. Okay, so it will be only 1 more. Okay, this would be the last one. Okay, 23rd. So we're gonna have a 2 plus a 3 and a plus a 4. So we'll make a total of 9. So at least when you get 9, you feel free. Okay, I found 9 ones, like 9 dates. So I'm right. Okay, so that's problem 9. Okay, let's do problem 10. This is the last problem for this video. Okay, so Maureen is keeping track of the mean of her quiz scores on this semester. Okay, the mean will be like the average. So for this one, I'm just going to assume this is M. Okay, so this is M. So if Maureen scores an 11 on the next quiz, her mean will increase by 1. If she scores an 11 on each of the next 3 quizzes, like her mean will increase by 2. What is the mean of her quiz scores currently? Okay, so if you don't understand, you read this question, you still don't know what to do. So you just have to come up with some numbers. Like, what if the numbers are like 1, 2, 3, 4, and 5? Okay. What is the average of these numbers? What do we do when we find the average? You add all of them, 1 plus 3 plus 3, and then you divide it by 5. Okay. So when you add all of these numbers together, it will be 15. Okay. When you add all of this number. So you divide it by the number. We have 5 numbers. So the average, the mean will be 3. Okay. So now let's go. How many numbers do we have? N numbers 5. Okay. So the sum of these 1 plus 2 plus 3 plus 4 plus 5 is always equal to the mean 3 multiplied by the number n. Okay, so m times n is always the sum of this number. Okay, now let's go. Imagine we add an 11 to this one. So we already have this number, mn, and then we add 11 to them. Okay, so the sum will increase. Okay, but because we added one number, we had 5 numbers, n, it will be n plus 1. Okay, we just add 11, one more number. And when we do so, m will also increase by 1. Okay, that's one equation. So here it says, what if we add like 3 11s? 1 11 plus 2 11 plus 3 11. Remember, the sum of these, 1 plus 2 plus 3, was m times n. Okay, plus 3 11s is 33. We had n numbers, in this case, for example, 5, it will be n plus 3. Okay, so, and then the mean will increase by 2. Okay, so there you go. You have 2 equations and you just need to solve them. And when you do so, you'll find m. Okay, so let's just start by the easiest one. Okay, I just cross multiply. So it will be mn plus 11 will be equal to mn plus m plus n plus 1. Okay, so mn, we subtract mn from both equations. So what we're going to have is m plus n is equal to 10. Okay, that's the first one. So I'm going to clean this because we have the result. So we just need to cross multiply this one. So we're going to have mn, so get capital, mn plus 33 is equal to m times n, again mn. We're going to have 2n plus, 3m plus 6. Okay, so again, mn's will be canceled. So what we're going to have is 3m plus 2n is equal to 27. Okay, so how do you deal with this? We have 2n over here. So I will multiply each term by a 2. And then 10 will be 20 like this. Okay, so, and then I'm going to subtract the 2 equations. Okay, this one, if it's equation 1, 1, this is equation 2. I'm going to go like equation 1 minus equation 2. Okay, so when we just write it this way, it will be 3m plus 2n minus 2m minus 2n is equal to 7. Okay, so n's will cancel. We're going to have 3m minus 2m is n. So as you see, the mean will be 7. Okay, so this is the end of this video. Remember, if you need coaching, you could book some lessons with me. You have the contact information. I will make more videos. So if you want to see other videos, make sure that you subscribe to the channel as well.